Welcome to part 5 of the Service Mapping Art of the Possible series. Today we'll explore leveraging machine learning for discovering applications and connection suggestions on your application service map. I'm Bill Ifland, Product Success Technical Director, and I'm excited to guide you through this innovative approach. Before we begin, let's look at the Safe Harbor Notice. Here's what we'll cover today. A quick review of the MediaWiki CIs, the technical aspects of machine learning-based connections, as well as implementation approaches, and finally, a live demo showcasing the capabilities of this feature. Let's start with the MediaWiki CIs. Recall, we're looking at the production application service stack, which has a load balancer that front ends 3 Apache web servers that connect to the MySQL database server. In this demo, the connection suggestion from the Apache to database server will be used rather than a connection pattern from the discovery. And I will highlight why it's not using the pattern. Again, machine learning is another form of top-down discovery. It helps you connect process to process without having to create connection patterns to parse strings in configuration data. Some of the technical aspects about maps with machine learning connections are the same as you would find for top-down with connection patterns. They're stored in the mapped application service class. They still have the service type of discovered or empty when not fully discovered, and do require the service mapping plugin. You still use an entry point for at least the first item or the first node on a service map. That top level node is determined by the discovery pattern for the entry point. It's the connection section that now become machine learning traffic based rather than pattern. Again, top-down application services are better suited for services where you need component relationship, process to process, port to port. Likewise, they are built automatically once given at least one entry point, and then the connections leverage traffic-based data that's collected during the horizontal discovery phase from the ADM and ADME probes. Those probes collects those running processes and the established open ports and the connections that they're making to other devices. Like before, there's many considerations when using top-down discovery. Perhaps you may want to use another method for a quick win to show your service CIs. However, machine learning connections can lighten the burden of having to develop custom connection patterns. You will require credentials and privileges for accessing the servers, but maybe not as significantly requires horizontal discovery, especially the ADM and ADME probes, to capture those open established connections. Similarly, you're still going to require IP ranges for your mid servers because the connection suggestions will point you to IPs downstream. And the IP ranges allow you to determine which mid server will be used to identify that next new connection. Here, with machine learning, you can create application discovery patterns using the application fingerprinting function, and you would be able to use those pattern stubs for horizontal discovery. Then you can use connection rules to add or remove suggestions based on the traffic information instead of interrogating configuration files. Those connections that are created by connection suggestion are TCP endpoints. So only other discovery patterns, other application discovery patterns that listen to TCP endpoints will be used to identify, which implies that host and process detection will still occur on that IP import. And then, as I mentioned earlier, the TCP endpoint patterns will only respond. Machine learning requires additional probe activity from horizontal discovery. ADM may be enough to get you started, but that will only see open connections during the discovery window. To find connections that are outside of your discovery windows, we suggest to use the ADME probe to watch for open connections that are established from machine to machine outside of your discovery windows. And then during the next discovery, we will pick up that payload and populate the running processes and TCP connection table. This becomes the source information for the machine learning to group clusters of processes and command lines, as well as produce connection suggestions for any existing service map. As before, we're working with a top-down application service. Generally, you're still using a web application or an HTTPS entry point. And in our case, we are omitting the word MediaWiki from our URL so that the Apache pattern cannot make the connection. Rather, we're forcing the TCP connection to be created by machine learning. You still need to have a knowledge of the MediaWiki architecture to know all the components. In this particular case, the source of our connection is the Apache web process that's running and listening on port 80, as well as knowing the MySQL server process running on port 3306. This becomes the vital data that machine learning leverages to create that connection suggestion. Now let's move over to the IFI instance for a live demo. Here in the IFI instance, we have the service operations workspace, and I've pulled up the application service for machine learning for our top-down MediaWiki service map. Notice we do not have the database server on this map at this time. And that's because the pattern was not successful. And this is where machine learning connection suggestions power comes in. It will help render the rest of the map for you. Before we get into those details, just as before, you can look at a application service record more than one way. The original way, of course, is on the table itself. A machine learning application service has essentially the same components for the entry point to get you started. Nothing new here. We can also see it here in the service mapping UI. You still add your entry point, but you also leverage traffic-based discovery, which is typically on by default. Previously, horizontal discovery was able to find the data necessary for the machine learning. The third way to see the service record, of course, is through the Manage Technical Services under CSDM menu. And here you'll see the CSDM relationships to the service and business service offering. And here it's still top down for our entry point. So here we have our application service again. And let's look at the discovery log. Apache server was identified. However, our pattern was not able to create any connections. And that's because the URL did not pass. The word MediaWiki was not found in the entry point. And this is where machine learning can provide the completion of your application services. So let's quickly look at the server. We know that this process is running on port 80 because we saw it from its not only its connection, but also from its attribute. And we know from the architecture that our MySQL server is listening on port 3306. So quickly looking at the running processes, we see that port 80 is open and listening on our app servers. Let's also quickly check for the database server. Notice that we also have our database server listening on port 3306, but we do not have a connection from our production application servers with a connecting to on port 3306. And because of that, we do not have a connection suggestion at this time. We only have connection suggestions based on port 443, as you saw here, 80 going to 443, but that's going outside of our lab to CrowdStrike, and that's not helpful. As I mentioned earlier, outside of the discovery schedule, the ADME probe is picking up the traffic data, looking at ports that are listening and connecting to on our servers. I'm going to emulate that traffic as well as the discovery and the machine learning suggestion by running our script here to pull the data into our system. Now we have port 80 process HTTPD connecting to two outbound connections, 443 and now our database 3306. And that should be visible now in our connection suggestion. So what does that mean, or how does that look on our service map? That would mean we have connection suggestions on our service map for our MySQL instance. We needed to tell the system how to process this data. Currently, the rules are inactive, and you may not want them to be on for all services. But for our demo today, I'm going to turn them on. First, I'm just going to show how you can manually add connection from the suggestions. Here it says it was added manually and who did it. If we go back to our service, it should refresh. It's going to identify process that's running on that port. Notice that the connection uses a TCP endpoint. The discovery log still doesn't show anything from the pattern creating this connection. It was actually created manually. You will see the traffic-based source equals true. The discovery log will show the identification process was executed for the SQL Server and created the CI. Now let's consider how we would automate this for all connections of type 3306. And we would do that through global rules. When shipped out of box, the rules are set to false. But we know that the SQL Server database port and process identify it as a MySQL instance. So we can use this out-of-box global rule to make our connection. So now I'm going to update the rule to active, and I'm going to rerun discovery here. And if we look at our suggestions, They're still undecided for the other two connections. Now you see that the connections were made, and likewise, they are traffic-based. If we come back to the connection suggestions and refresh, we'll now see that it was added by rule and that the mid server did that while it ran top-down discovery. To reiterate, what's necessary from our discovery is we need a listening port and a connecting to port for the machine learning to identify potential connections. And here those connections were Apache server to the Microsoft SQL instance. This is the list of configuration items that were identified before machine learning created the connections. Let's see how this was updated after the connections were added. Notice we have 28 CIs over 11 classes. Now we have 2 more classes introduced, as well as 9 more configuration items. And those came from the additional SQL Server Instance CI and the TCP endpoint and data that was associated with that server. And this concludes this demo. Thank you again for joining me in this 5-part series. Hopefully you have learned how each application service population method can be used and how you can deliver winning outcomes in your ServiceNow deployment.